Hello, everyone. Can you hear me well? My name is Khalid Hassan. I'm a software development lead manager for the online feature services. And with me, Nathan, he's a senior product engineer with the team. We're gonna tell you the story of the online feature service and the best practices, how we can use it efficiently. It's a server-side session, so it might be different than any other session you have been in the client side. So we're gonna focus on the server side, and we'll give you the secret sauce, how to use the online feature service the same way the Esri SDK is using it. So we're gonna start by introducing a summary of what the online feature services is. And I'm gonna give you also the road ahead, where we're going in the next year and so for the online feature services. So we are a SaaS product, totally written to run in the cloud, take advantage of the cloud. Our business logic run the location tracking services, OGC feature, and general feature services. You will see indoors, workflow manager, and other oriented imagery all running in the top of the online feature services. We have a full support of the WebGIS model. We support table, feature classes, domain, subtype, contingent values, attachment, sync. So it's pretty much a full solution where you can host your data efficiently on the cloud. We have an admin API. Without stopping the services, you should be able to add layers, add field, add indices, and totally manage your feature services. We do support a strong support for sync and offline and portal collaboration. And we support viral load if you are basically follow our best practices. You can scale up your data store with different premium data store that's available in the platform. So this is basically the fourth topic that we're gonna cover. General area that's including the new stuff that's coming in online. We'll talk about the performance, scalability of that, and security aspect of the online feature services, and some cost, what is the cost of using it, and how to optimize your cost. So in order to understand how it works, you need to understand 3 tiers architecture we have in the system. So you'll see there is a client tiers. That's where mobile client and browser and desktop client lives. You'll have the CDN tier in the middle, and then we have the server tier. Normally, you don't talk to us directly. You're actually talking to the middle tier, the CDN. That's where caching happens. It's a massive cache. And then the client also has its own cache. Server has its own cache. So the power of online feature services is how you can take advantage of the caching infrastructure we have to scale your services. And we're gonna talk a little bit more about this in the next few slides. So you can see that the request comes from the client, it goes to the CDN check the max age, is the response it has, expire if not, then it actually go back to the server. The server is always current. So it will check your query, is it in the cache, is it obsolete? And if it's not up to date, it goes to the database and get the response cache, the response, and then return it back to you and cache it for future use. So this is basically the high-level architecture of the system. So in order to, the keys to efficient sharing of data at scale require you to understand the caching tier of the system. And you have different options. You can actually go into tile request, whether it's a vector tile or raster tile and 3D tiles. That give you the best performance, but you won't get features back because there is no database involved in that kind of solution. But the idea here is to, ideally, you should be able to use it in some workflow and then delegate to the feature service in some other workflows. So what we have in the online feature service is something called the dynamic feature tile. So it is similar to the vector tile, except it has an advantage where the data is always current. So if the data get changed, we cook a new tile on the fly and return it back to you. And if it is not stale, we're giving to you back the same way vector tile cached on the cloud. So this is basically the beauty of the infrastructure we have. So you should be able to take advantage of that to scale your app and maps. And also we have the cache hint where if you feel your query is frequently used, you can ask the server, can you cache this for me? So you don't actually want to go to the database. So the idea here is to reduce the amount of load to your database because the database takes 200 connections. But what if you want to actually scale to 1 million requests per second? What would you do? So basically, you need to basically understand that and try to use the SDK we have, which actually this is how it does it, or if you hit the REST API, you have to understand the result type and the cache hint and so on. So the idea here is just to be able to use response caching in CDN and in the server and in the client, and control that with the max age. So the max age is just telling the client how much it holds in time before it sends the request back to the server. So the higher the value, the better the performance you get. But of course, it's just you're gonna have to see if that works for your flow and how current your display is. So basically, in addition to that, we take advantage, Esri takes care of the compute part. So when request increases, we increase the number of machines that need to handle your request. We take care of that, but you need to take care of the data store if you need a unique query. So if your query is not cached, your data store, you need to see if your load deserve to go higher into a different kind of tier in your data store. We start from standard all the way to M4. So for best practice, you just need to say, basically, what is the rate limit of your data store? You need to watch out for that, because that's important to understand in order to scale your system. We do enforce rate limiting in query API, all the query APIs, and query analytics and query top feature and so on. Async API also has a limit. And if you got into one of those situations, you need to think about the strategy. Either you need to create views, a read-only view, increase the max age, or you need to use cache hint and feature tile. Rather than going to the database, you need to basically take advantage of the cache. And you might need to retry and back off, because your quota or your rate limit is per minute. So when you go to the next minute, it's a new quota that's coming to you. And it's very large, it's not very small, so it satisfies your need. And if caching is not your solution because you need a current information, you probably need to think about the upgrade of the data store. Here is the limit we have. We use something called a request unit. The request unit measures how expensive your query is. So if you are doing aggregation, for instance, that costs you 3 units. If you are doing a geometry plus attribute query, then you're talking about 2 units. All other query will be like 1 unit. So if you are one of those tiers, the standard one is shared infrastructure, the shared server with other orgs, which mean you might be affected by the noisy neighbor. So your query will give you 10,000 K per minute. However, it wouldn't be consistent. So sometimes up, sometimes down, based on the other use. But if you want to get your dedicated server, database server, then you need to think about the premium data store that we have. As you can see, if your data is read-only, you get double the amount, because we actually give you a free copy of your data on the cloud. So you'll have a primary database and you have a secondary database. So when the load comes to the data, if the data is read-only or it hasn't changed for more than 30 seconds, then you're probably going to get the load distributed into those 2 copies. So you get double the rate limit that you would get from the standard or from your database, because we actually distribute the query over 2 copies instead of 1. We take care of synchronizing the copy, by the way. So this is something that you should know. You shouldn't worry about. There is another concept called the basic query mode. When you are working in a public layer, we need to secure your services, and that's because you expose the layer publicly. What would happen is, if somebody get a hold of your layer and your intention is to share it for display purposes, they might be able to abuse that by using analytic queries or doing a chart or something that is not intended to. So you'll see cacheable query for public layer is 100% of the rate limits. And then you'll see the basic, which is non-cache query, will be 60%. Advanced query, it will be 30%, and then the 5% for analytics. So that's basically only for public layer. So if you are not sharing it publicly, you don't need to worry about that. For async, we do enforce limits, as you can see, for different async API, editing, append, export. You have a limit concurrently, which means how many concurrent jobs you can execute for your org concurrently at the same time. And then total also concurrently is 256. But then per hour also there is some limits on how many API you can call asynchronously. One thing to mention here is that the export is cached. which means it doesn't count. So if your data hasn't changed and you do export 5, 10 times, it counts only as one job, because we don't actually have to go to the database to fetch that. We cache that export to whatever format you are using the export from. So in order to understand the system also, we give you helpful information. It's a response header. So the response header, it allows you to understand where the response is coming from. It could come from the database, which is the worst case, and then it can come from the cache, and that means you are doing a good job in terms of running your app. So some of the header of importance is the request units per minute. This is actually telling you what are you using now for the current minute, for current request, versus the max allowed to you. So you get like 5, comma, semicolon, and then you'd say 10,000, so or 5,000. That's actually telling you where you are in the current minutes. Also, it will tell you a cache hint feature. It's coming from the cache. It will tell you that response header is a true. Feature tile cache is true. And all of these will allow you where the response is coming from, so you can understand if you are scaling well for your app or not. Let's just talk about like switching gears. So we talked about like your data store, and you talked about how you take advantage of cache and how you scale that. But the other talk I just need to mention here is very important, is how you update your data. Is also, there are lots of best practices how you do that. We identify 4 different type, or let's just say ways, methods you can update your data. We're all familiar with the publish with overwrite, and what's happening is you have your feature services, and then you get a new file that has your data, that has the updated data, and you go and just update and say, I want to overwrite my data. What's going to happen in that case is the system will delete your feature services, and then you'll get the new data, but it might be after an hour, 2 hours, 3 hours. It depends on how much data you have in the new file. So that's not really recommended in most cases. But then we have the Append API. Append API is a very powerful API with an upsert capabilities, where it can actually suck the data from a very large file, and with doing things in parallel to allow you to cut the time of copying the data into 10, 20% basically of what it should be if you do it in one. And then it allows you to update data if it exists, add new data if it doesn't exist. That's the upsert capabilities. So we are adding more support, more capabilities into that, including the truncate. So if you want to do the same thing as publish with overwrite, we're actually telling you, hey, use an upsert with a truncate option. What we do, we copy everything, and then just before we merge the data, we truncate the data and then copy, or actually replace the data with the new copy. That makes the downtime very small, very tiny. So that basically allow you to keep working with the data while this is happening. The view update, we call it view swizzling or view update. It's like, instead of exposing the data as a source feature services, we have a view, and you expose only the view rather than the source. And then when time comes to update your data, you create another one. And then the other one is called like QA in this case. And your data is accessible through the view at that time. And when you're done with the QA process, and be sure all the data is good, you ask the view to swivel itself from the source to the QA services, and then you delete the old services. So during that process, you might accumulate double the space that you need, but that allow you to seamlessly be sure your app or your map is working until the data gets updated. The whole process of swizzling takes a few seconds, so you have a very small downtime. And then we have the sync and collaboration. It's the best approach to sync data. If you have an enterprise to online or online to another online, that's all can be used for that. We are doing, actually in March release, we did Append Enhancement that allow you to do more, you actually use more methods to update your data. And that's through, for instance, as I said, the truncate existing. So you can truncate the data while we're copying the data after we copy the data. So what people used to do, truncate the data and copy the data. And that was actually causing problem, because when you truncate the data, basically you can't use your services anymore. So we actually delay the process until we copy all the data and ready to merge with your own data. So now truncate existing is valid and available to append. We add a way where when we copy data, you can define a source filter, and also allow you to partition append. As we'll see, that's another method we are adding, where you can have a big file, and you can submit many appends. Each one use different filter. So we'll cut down the time into 10% of the time that you need to actually copy and update your data. And we are adding a feature surface as an append source format, so you can actually copy data from one surface to another, or from the same surface to itself. And at the same time, it allows you to clone your surfaces. So if you want to clone your surfaces, you can actually use append to do that. So this is the two additional workflow, the two methods that we have to update. Normally for big data, we recommend using this one. It's actually being used by the data pipeline team. And the way it works is that we introduce a new format called JSON-L. And the JSON-L is no more than like a header that defines the fields and then a bunch of records. You can actually get all of these data into the server in chunk. And then after you get all of these data in chunk, as you can see in the picture here, you tell us, hey, I want to append my data from an upload ID. And the upload ID will come after you upload your data, you have this upload ID. So you call append from that upload ID. The server takes care of accumulating all of those chunks and parallel the process and basically get your data in the destination layer. So this is basically, if you have too many views, so if you have like 100 views and you want to update all of these views, if you go to the swap view, you probably have to go one by one. But this one is actually allowing you to go to the source of the data and do a source. All the views will actually see the change. The other approach we recommend also is to use append plus filters. As I said, you can have 100 million record feature in a file GDB. You can chunk that to online feature services. You get an upload ID out of that, and then you actually execute as many append as long as you are within the 256 limits concurrently or however works for your organization. And then just pass this file with different filter. The system will actually accumulate all of these and actually append that to your feature services. So this is basically, if you care about performance and chunk your upload and your append, that's all basically available to you. As far as the March release, we have many functionality added to the system. The first one is the 3D. So 3D is available. You can actually basically publish data from Pro or online, from file GDB or SD file. You can create new assets, query, editing, and change tracking support. Also, you can track changes for 3D object. And also you can convert from one format to another, GLB to TLF and so on. The feature set for 3D layer is the backbone. It's actually the foundation of the scene layer. So the scene layer based on that, and you can always rebuild scene partially or fully by the changes that's happening that we track in the feature service. You can also, we are working in the create an empty 3D layer. It's coming in the next release. New date field types is added to online. You can work with date only, time only, and date time offset. So if you don't need to store date plus time, like you want to store like working hours or so, you can basically use the time only and so on. Stored in the database, you save space, and we'll always use ISO ISO string representation when you query or when you edit. You always communicate with the SQL 92 when you query the feature surface with those new columns. Unfortunately, sync didn't make it. So we are working on that. So if you have one of those columns, you probably will not be able to use offline until the next release or so. So we are working with the SDK team to integrate that. However, you still can export your data and preserve the date types. So those are the new things that's coming. And we are working in IANA support for the time zone. If you're caring about that, we've been supporting Windows for so long. This is basically the next step to support the new spec in the time zone. Encourage you to use the BBF format. It's like the same format as vector tile, so we have a native support to that. It's keep your traffic small, encoding or serialization and deserialization. This is how the SDK and all of the JavaScript and the other mobile SDK and so on communicate with the feature services. We no longer recommend JSON, so basically BBF is supported across all languages. You don't need anything from us. We'll give you the file, the proto file. We'll give you the C# or the .NET, whatever class, and you can read and write to that. All queries support BBF, and we are working in supporting editing also through BBF as well. We have a public repo. You can actually look at that. It is the same technology that's actually working in the vector tile. TrueCurve is coming to online in June release. We will basically support only circular arc. It's going to be natively stored in the database. And we support all operation, including sync. And for advanced curve support, like elliptic arcs and Bezier curve, that is not coming in June, and it's coming in few releases, maybe next year. And for those kind of curve, we didn't specify the curve on the fly. So you still can host your data for any type of curve, but only preserve the circular arc curve in online. With that, I'm going to leave you with Nathan to talk about the caching and maybe Append API as well usage.
Good afternoon, everyone. My name is Nathan Wu. I'm as a senior product engineer for the hosted feature service team. So next thing we're going to show you is some demos. So that Khalid talking about, it's good to show how it looks like. So here on the map, we see this is a simple points with a bunch of salesman data. We can briefly see the mention. We have a couple of new data type like a date only, time only, timestamp offset, and big int. So this is just like a big improvement that we have before. So what I'm going to do next is just show you some little tricks about how we using the cache. Like Khalid mentioned, we always providing you guys the service cache on the fly, but there are some situations. Let's see, there are some query, your client or your customer keep using it, and you don't want to abuse the same specific query over the same times. What happened is we can provide you these options is called a cache hint. So cache hint means if you know this this particular query being sent a couple of times, if you turn it on to true, the system will recognize it. The first time we'll send it as normal request, we send you the data from the cloud, and then the next time if some other people are querying the same exactly the query, and we will actually directly send it from the cache rather from the database anymore. So what we can do quick test is if we check the query, we return as a JSON, right? So the first time, if we open the developer tools on the browser, if we check in the headers, there's nothing special. But next time when we actually querying again, you will see a cache hint parameters headers will be show up again. So when I send a request again, the second time, you will see here, right? So Esri cache hint features equals to true, which means that this is not a data that you consume from the server anymore, it's just from the cache. That's one little thing I show you. The other thing I'm going to show you in the coming is we mentioned about the unit or the request unit. So we have a unit 1, 2, 3, which represent a different unit that you cost. The normal one we just send like when you're trying to just get one particular IDs, and that was really simple query. We will return you the request ID is 1. So once I send this particular query, which is actually query the object ID, which is equal to 1, and then we will see here the query request unit is 1. That's pretty straightforward. And here another thing you wanted to take a look is about like Khalid mentioned about the rate limiting, right? So you don't want to be get cars or get a warning if we abuse the system. So here we see the Esri org request units per minute. It actually giving you the idea. So right now in the minute we only have one request, and the maximize of this request is 6,000. So that will give you a little hint about how do you make sure your query within the max. The next one we're going to show you is a little bit of complicated query, which is you wanted to, let's see how many features in this particular layers you have, right? We put a 1 equal to 1, which means you want to get all the features in here. And if we send this request, if we check in the header here, you will see here this Esri query request unit will become 2, right? It's because it's a little bit more expensive query. And when we take a look about this query request unit per minute, now it bumped to 2, right? Because previously we sent 1 request and we're still within the 1 minute. And as long as you not maximize the 6K here, we're all good. So the last one I show you is the most expensive one query. So those kind of a query are related to a lot of like statistics. Like you want aggregating or put some like on the fly result with a particular new fields. Those are more expensive a query. That's we cost like a 3 unit. For this particular query, I'm doing is actually I'm trying to do auto statistics and trying to get the count of all these particular fields. If I click the query and if we check the header here, we will see here the query request unit will bump to the 3, and the per minute is actually coming to 3. Because they have a different categories, you see that this 3,000 is different with the 6K because there are different categories. So in different categories, we have a different limit of the query. Without being this said, let's go into another demo, which I'm going to show you, which is kind of a new we have is, we previously have a append that we append from different file. We have CSV, file geodatabase, SQLite, those are file. But in the last release, which is on February, we have a new append feature services, which means now you can append a feature services to another feature services, and you don't have to worry about moving the stuff here and there. So here we're gonna show you the data quick. So this is the data that we are just showing you at the beginning, right? So right now we only have 38 records, right? And then I'm trying to append a new feature, which this data will have like a more than 10K, right? So this is a large data set. We want to put this one into the smaller one. And before I doing that, I want to show you something you probably gonna to take a look at when you're doing in the daily job is what happens if you have a different schema, right? What I mean is like if I have a different field name, is not matching 100%, how do I do that? It's not a big deal. We can actually help you to handle those. So in this one, it's like the smaller data set. We see those new data type, right? Date only, time only. This is their field name, right? And we compared with the other one, and you will see it has different value. Different field name. So let's see here. So those data you see have a new data only, new time only, right? New timestamp offset. So there are different names. What we can do is we using something called field mapping. What is field mapping doing? It's basically you put your source as name compared with your destination name, right? In this case, you can put a big int correlated with a new big int, right? And the same thing for date only and new date only. So once we set up this way, it will helping you to mapping those different field names to know each other and make sure they are synced the same way. And the other thing I'm doing is this is called a source filter, which means you probably have your own flavor, right? You don't want to be, let's see, you don't want to append all the features from the existing big data, and you have some specific requirement. We can actually put a SQL clause here as well. In this case, I put a sales amount over the 5K, which means I only want interest in those data to be append. And the other options are pretty straightforward. The append upload format is a feature service, and this one is just your feature services ID. So let's do a quick test and see how it works. If I send this request, and we open this particular, it's all because, like Clay said, now all the append are going to the async, and it will all go into the async. So see here, the result is actually completed. It's actually append 6,521 features, and that's all from the demo. Let's continue back to Clay.
So we just switch into. Sorry. So we switch into a different area of the best practices performance. The top of the list is the multiscale geometry. So this is only needed when you have a polyline and polygon data that exceed 500,000 vertices. Imagine you have a polygon that has 500,000 vertices. How can we handle that? So we introduced the multiscale geometry, which means we generalize the geometry without losing the original geometry. So that's all transparent to you during publishing and append, but you get the chance also to build it if you have an old data set that doesn't have that or an old layer, or turn it off if you don't need it or whatever reason that you need to. So the way it works is that it's transparent to you. When you edit your data, we maintain the extra copy that we have. At the same time, at the execution time, we pick the right geometry for the right scale. So when we are getting the max allowable offset, or when we get the quantization tolerance, we pick the geometry that actually allow you to perform well in your app. And that's where the multiscale geometry is. It is better for your database, and it's also better for compute in our side. And if you want to see if your data set has that, you go to the JSON representation of your layer, and if you see multiscale geometry info, it will tell you how many geometry you have. Here you have geometry 1, 3, 5, 7, and 9. And that actually is just an extra column with your layer. Only needed, and one thing you just have to remember, if you turn it off, you're going to get throttled. You're going to get throttled at 60 requests per minute. So that's the downside of this. That's why we're trying to make it transparent. But if you try to turn it off through the admin API or from the UX, then they probably, or you forgot to build it, you will have a problem. Attachment, we have a very strong support for attachment. A very large attachment also supported if you are using a multi-part. So each single part or each single attachment cannot exceed 10 meg, but you can use multi-part and upload all of these. We take care of accumulating all the parts for the big attachment. So if you have a video, 10 gig, no problem. The number of parts cannot exceed 5,000. That's basically the limits. If you want to download the attachment, rather than getting the JSON, you can actually request us to return a URL to the external blob that we have. So you can display movie, for instance. And the last thing is that the predefined MIME types, HTML is not supported in one of those because of the risk for cross-site scripting. But we are working in allowing you to control the MIME type that you need to be supported for attachment. Thumbnail is supported for those predefined size. If you request W equal, we take care of generating thumbnail on the fly if needed, and cache it. And as long as your attachment hasn't changed, you are not paying any cost. There is nothing for you, so it's basically will come from the cache. We also have a searchable keyword property. You can set in the attachment that you can search for the attachment based on that keyword. We integrate well with the EXIF, which means if it has a location info, we will be able to read it and even convert it to a feature if needed. And that's what the UX is doing with if you're familiar with the publish image collection, we take care of translating location from EXIF into a feature with attachment based on the location stored within the EXIF. You can get this info back from the attachment through an additional property called return metadata in the REST API. New in March release, we are giving you like a very performant API called queryBins. So rather than actually trying to write the SQL to bin your data and be able to draw a histogram or to have a chart, we'll give you an API that's returning you the data ready to be rendered. This is where we are going with the charting team and the dashboard and so on. And you can create a set of bins or a series of bins for numeric and date bins as well. And the default is to return the count for each bin, and you can actually request to return the centroid for the data within each bin, or the convex hull, or the extent. You can customize the information that we need to search for to retain this bin info through a spatial or attribute query. And here is some of the example I have. Let me just see if one of those work with the connection. So this one is allowing you to pin the data based on time. So here you can just say, I'm interested to get, you can see that the query is called queryBins, and it is on the layer and support async and synchronous API. And you say, I'm interested in the date column, and I want to do it every 10 months. I want to bin every 10 months, and I want to do it starting 1999 until 2005 April. And I want to convert, I want to do that calculation and the aggregation for my bins on the Pacific time zone. So what we do, we go to the server, project the data to the Pacific time zone, calculate the aggregation, and returning you a very simple information, the lower boundary, the higher boundary, the upper boundary, and the frequency. I have more examples onto that, but please look in the documentation. It's a very powerful API. this is where we're going. This is something that we all should be using from now on. I have more examples, but I'm not sure if I have the time to show all of them all, but this, you get the idea. You see here. One other thing I just like to mention, and I keep emphasizing it, like in order to query the data efficiently, you need to create indices. Everybody knows this. And, but once your column reaches 1760 bytes, you can't create an attribute index anymore. And you need to create what we call it a full-text index. The full-text index allows you to do a Google type search, auto-suggest, and so on. This is something available to you. You can add an index similar to any other index, and full text less than 1760 or higher, it doesn't matter, as long as you can actually query the data later on with the expression that you see here. So full text, you can specify full text plus where clause plus a geometry spatial query. Combine all of these to get the result back. And what we see some people do the like query in the expression. This is, we're trying to ban this because you are killing your data store. The moment you start using like with the wildcard predefined in the beginning, what would happen is you are technically table scan your data. So if you have a 10 million record or 20 million record, we have to scan all of these. We can't use the index. So, but you can actually use a full text index for that. So try to avoid using the beginning wildcard when you're doing like at least, but we advise you not to use it. We haven't banned it yet, but we will reach the customer when that happens because you are really not going to get the performance you need. And it's very simple. It's integrated with the UX in the add index, and also in the query part, the auto suggest is actually leveraging the full text. And it's very simple. When you do the query, you pass the field name, county, one or more, and you say, I'm looking for San Bernardino, and the search type is simple. So we will actually do the Google type query, and we'll get you anything that matches that San Bernardino, but you can use a prefix. You say, my street name is star, or you can actually do an advanced kind of query to get the result back from our system. We're seeing people do some inefficient SQL query. I'd like to mention that that's somehow, I'd like to get the word out. Like people do where ID equal 5 or ID equal 5, 6, 7, 8. You are limited to a couple of hundred of those expressions. But please try to rewrite this into a where clause where you say ID in. It's very simple, and you get a few thousand. Instead of a few hundred, you get a few thousand value in your query. So this is basically something you should watch out for because we are seeing it. We are blocking anything beyond certain limits. So that's basically the data store doesn't support it. So we need to commit to a best SQL that we can write. Sync, it is as buffer as it can be. Creating an offline map is expensive. The recommendation we have is to use a pre-planned. So pre-planned is something that the admin of the organization can create upfront. Everybody else can actually consume it, register it with the system, and then they can communicate back with the feature services. So it's basically you can get your own copy, but just copy it once, and then distribute it to all the mobile client that you have or any client that you have. We're still not supporting schema changes. So even though we support sync when a schema change in either side, but basically you might need to create an offline map for that. And then we support sync on views and portal collaboration one way or two ways. And the conflict policy is something we are working on. What is conflict policy is allowing you to control what happens when you have a conflict. The server change a feature, the client is sending the same feature in different values. Then you can say which one should that win. So that's the conflict policy we have. I'd like to spend some time on the webhooks because this is something like least understood by many people. So the webhook is no more than, rather than you checking the system, give me the data where the current time stamps minus 5 seconds. That doesn't work. It's going to throttle your data store. It doesn't work at all. So now, instead of keep checking the system and for query that's not cacheable, you probably need to create a new webhook and wait for us to tell you. So we're telling you, hey, you have attachment changes, you have new feature coming, or you have metadata got changed. And all of this can be communicated if you just tell us, create one of those webhooks, tell us that's the URL you need to tell us this info. This is all what the webhook is for. And last year, we had 5 build services. Now we have 10, based on the recommendation from you guys, request. It's a secured way to receive the info from us. You can pass a secret key when you create the webhook. We'll give you a signature info based on the payload, so you can actually guarantee that the information is coming from us. We support all third-party out there, and Integromat and Microsoft Flow is on the top of the list. The minimum is 20 seconds. So what happened is, if you edit data less than 20 seconds, you're going to have to wait until 20 seconds. We are working in improving the system, but that's the current option we have. You can opt in for all changes or subset. If you care only about attachment, you create a webhook based on attachment and feature created or feature updated and so on. In the release coming, in March release, we support a global view of the webhooks in the system. It's called the org webhooks, so you can get a list of all the webhooks in the system. You can order those by service name or owner name. You can reassign the owner of the webhooks, and you can control some setting on the webhook. So I'm going to show you like a very simple demo about that. So here is the org webhook. You can see your org is here, the admin, and this is the list of webhooks. This is all the webhooks you have for the org admin to control. And they can actually look at individual webhooks. They can edit it, they can check the status, you can reassign the owner, and so on. So it's basically the global view that you can get from the org admin that can control. And this is, we are building UX in the top of this API. So the UX is coming, hopefully in the UC, that's the plan. And that's going to come to satisfy or simplify you working with the webhook. Webhook requires something very important, which is change tracking. So change tracking is something that you need to enable in your feature services in order to work with the webhook. So you enable, which is actually, if you go to the UX, it's say change feature changes or change editing changes. And I think once you have that, you can actually build a webhook solution. So with that, this is the webhook enhancement. The last part is the security, which is as important as all the other topics. So the feature service is totally secured with different kind of ways or methods. So you can actually make it through a token validation through private public use case, or you can actually use a custom rule to revoke permission to someone to access your services, or define the capabilities of each services, or using ownership-based access control. All of these control what can you do with your services. I'd like to mention a couple of things. One of them is the ownership-based access control. This is on the feature by feature. So if you create some feature and you want to prevent people from seeing it, you need to turn on editor tracking, and you need to turn on ownership-based access control. You can see allow other to query true. You can make it false. At any point in time, you can change any of these. You can customize it and prevent people from deleting your data. So you can actually control this feature by feature. That's the ownership-based access control. You can make it layer versus surface, so you even customize it for each individual layer. You can even customize it in views, as we will see in a second. View is another way to secure your data. So instead of exposing your data directly to your consumer, you can actually create views, and you can create lots of views. We've seen 3,000 views being created from one feature services. And view is no more than a definition. So it doesn't have a storage. So if you can see here, you have a source that has a layer 1 and layer 3 that point to two tables in the database. It has a relationship in between. You can create two views, one that point to layer 0, another one layer and layer 0 as well. So it's actually two different ones. And you can actually customize the filters, and you can customize even the ID of each layers in each one. So this actually can secure you. And what you can do also is what we talked about before is the max age. You can set a max age on the view different than the source. So if you expose your data to a consumer, then you probably can actually scale your system much better, because you probably don't want to show them the latest. Or if you want, you can basically reduce or increase the amount of the max age that you're using. SQL injection is an XSS prevention is something that built in the system to secure your data. And basically, you don't need to do anything except that if you're trying to put an HTML tag in a text column, and that is not within the whitelist that we have in the system, either the content will be encoded or rejected based on how you configure the system. So if you want the content to get in, you can actually say, I want to actually encode it. You'll actually replace the content with some character will be to change the less than and greater than to basically prevent the client-side code from getting executed and execute logic that will be harmful for your application. SQL injection is prevented through a standardized SQL. You can only pass SQL 92 to us. We rewrite the SQL that can work across all data stores. So basically, you don't have to write native SQL anymore, say I'm dealing with Oracle or SQL Server. No, just pass a SQL 92 and we'll take care of validating your SQL, be sure it's free from SQL injection, and we'll write what we need to write to make it work on the actual data store. Last piece, which is the cost and the upgrade when you need it. As we all know that the standard data store is a shared resource model. That means you're sharing the database server with others, which means like you might not get consistency. In the morning it might be okay, in the afternoon might not. And basically that's something that if that's not needed or you want to recover from that, then you probably have to think about the premium data store where you get your own server. We have different flavor of that where you can get heavy, like if you have a heavy queries, non-cacheable query, you have a heavy editing, or you have 4,000 editor happening at the same time, you probably need to think about premium data store. You can, even if you need more space, more disk space up to 4 terabytes, then you might need to get M4. And the other thing is that you are getting a dedicated hardware resources in the database side. This is something that might be required for this kind of workflow that need kind of heavy queries and concurrent user access. And we have many tiers available, and it's fixed cost per month. But if when you use a standard and the cost getting closer, you probably need to go to M1. So, because you're paying in the standard, you pay per storage. So if you accumulate 1 terabyte, you probably need to compare to the M1. M1 would be better for you. The last thing is like where we're going in 2024 and beyond. We still continue to support the open OGC out there, the open API and the open source software. So we support the OGC feature natively on online data. We still working in the SQL text and JSON, the query format. We support SQL, so you can talk to the OGC feature in online using SQL the same way you talk to feature services. We are working on the editing story. ArcGIS expression and attribute rule is coming. And we keep advancing the data modeling in online with shared template that's coming in June, probably in the fall, it depends, and parser fabric. So we are moving into parser fabric the same way we moved into 3D. We are moving into a parser fabric as well. So it's something coming later this year. Big data store is coming to online as well. You should be able to have an efficient solution for temporal data and be able to shard the data. You no longer will have a table that has 5 billion features. You will have like shard the data based on an attributes or shared spatially. So will be efficient. If I say, give me the data within January, I don't actually have to go through all the data in all years that you have. It's gonna go January 2024, and it will go to a smaller table. It will be better for you, perform better, and even if you want to delete the data, you can only delete the January table without actually having to do a very expensive operation to delete your data. And last but not the least, the open API. We are committed to that, and we will be able to support this shortly this year. We'll be able to use one of those, all of the tools available that work on the top of the online feature services, the same way working on any other API. So with that, I think I should be done, and we are now open for questions. Thank you. For which part? For
the arcade expression attribute groups for hosted services.
I think it's going to be later in the year, not in the UC, for sure. Yeah, we haven't started working on that yet, so yeah.
Hi, for the CDN caching,
yeah.
If you have, say, a long time, like 60 minutes, but, you update it, your layer once a day, can you like trigger a refresh of that cache one time or something? Can you control that? Does that make sense?
The only thing you can control is the max age. So let's just say you said the max age is 1 hour. Then the data will stay in the cache for 1 hour. If you make it one day, then it stays in the cache, regardless of what you do in the server.
Right.
But if the request goes to the server, you're going to get the latest, no matter what.
Right.
You know what I mean? So that's how it works, even in the browser, the same way.
Right.
Does this make sense?
I think so. Okay, thank you.
When using ArcGIS Enterprise portal hosted layers there, do you also get access to those response headers, Esri response headers?
Are you saying the response header for enterprise?
Yes.
Yeah, that's not supported currently, no.
Okay.
The cost of the Premium Datastore tiers just went up pretty significantly. Just curious if there's any roadmap of future price
do what?
increases.
To do what? Sorry?
The price of like the M1, M2,
Yeah.
M3 like jumped a whole bunch this year. Just curious if there's any forecast.
I mean, another data store or a better or a reduced price, or what do you mean?
If you have questions about the pricing mechanism or what happened with the pricing in the last year, I'll be in the showcase in the Premium Datastore section, which is inside of online. So you're welcome to bring that question there.
Sounds like space talk.
No, there's nothing imminent to tell anyone.
Yeah.
I'm saying that Colette is,
Yeah.
lead engineer and
Makes sense.
isn't getting to the pricing.
No, if you talk about pricing, I'm not the right person. I'm not there. I don't know how much it costs even, so.
What is the best practice for the upper limit of a webhook interval?
I think right now it's 20 seconds, but there's no upper. I mean, you can make it like whatever, you know what I mean?
Best practice. If you make it too big, you might.
Yeah, I guess the payload will change, but the way it works is very simple. You make it smaller to see if you can take the traffic. Let's just say you said every 20 seconds. We're going to keep calling you. Every time you change your data, we're going to call you. Can you take the load? It's up to you. But if you don't, and you say it's an hour, then what we do, we're telling you there are changes, new feature, new attachment, and so on. Then you go back, another call to get the changes back, so that the changes will be bigger than going when it's 10 seconds or 20 seconds or so on. So the change is relative to the time you waited. You know what I mean? And how many changes you made to the feature services, yes. Does this make sense? No? There's no upper limit for us. It depends on you. Yeah, you could do whatever. Yeah.
Because after that, you probably have accumulate a lot of records, right? Depends on how to filter it.
You are the first one who was asking for the upper, because people asking for the lower. They're saying 20 seconds, it's too big. You know what I mean? So they want it to be 10 seconds because they want the changes right there, And but I think we really don't have any. Best practice, it depends on how much you can digest. You know what I mean? If you make it 1 month, you might get 1 million feature back, so. Looks like.
We've been experiencing where the status URL change, we call back and make sure it's completed.
Yeah.
And it was taking only like 35 to 45 seconds to keep hitting that URL to look for the completed. And a couple of months ago, we started noticing that like taking 7 minutes now. We're only on a standard data store. Can you speak to anything why that might have changed?
Yeah, I think the async, the way it works in async is that when you submit an async job, it goes to a queue, and based on how busy the infrastructure is, we will pick that. We have a worker that's running to execute your job, and once we started the job, we update the job status. So if it takes 7, if you don't see in progress, if you see pending, that means it's still in the queue. But if you see in progress and takes 7 minutes, then we have a problem, because it shouldn't take, for a smaller job, it shouldn't take 7 minutes. You know what I mean? So most likely sitting on the queue, waiting for a free machine to do the work. Okay. But we'd like to hear about that. I mean, like, if something in our queue system, then we need to improve the,
You mentioned about the advantages of using Append. I'm wondering what's the number of features that, starting at which number of features is more convenient to use Append than a normal update?
Oh, how many features you can, so the question is how many features you can do in a single append?
No, like is it even better, more efficient, just sending many appends
Yeah.
with one single record?
Yeah.
Is that
Yeah, I
Very
think this is, yeah. So the question is like, is it better to do many appends versus one big append?
No. It's like there is a feature layer that is receiving a lot of inserts.
Yeah.
Just inserts,
Yeah.
like from different sources.
Yeah.
Okay. Is that still better to use append? Would that?
Oh, I got it. Yeah, so I think you are comparing append against maybe an apply edit.
Yes.
Oh, okay, yeah. So apply edit is not going to scale you well at all because you are working into the web tier. So we're telling people to do chunking for apply edit, for instance. We're telling people to use apply edit with async in order to get lots of features, right? In order to get lots, but at some point you're going to hit kind of a timeout. At some point, if you keep overloading the system, you're going to hit the timeout. However, append is for a data loading. You know, if you just want to get few feature out there, you know, maybe every once in a while within 1,000 feature, maybe 500 feature in each batch, it will be okay. But you might have to worry about like how many you do per minute because you might time out in between. But append is an async, so you don't have any kind of limitation there. So.
Okay. No, my scenario is more like a data collection.
Yeah.
Like a large data collection
Yeah.
scenario from multiple devices.
Okay.
Okay. So there is a large amount of inserts or
Yeah.
apply edits or inserts
Yeah.
coming from multiple sources.
Yeah.
Like, but very
Yeah.
often.
Yeah. I hear you. I think this is where you are getting into like a location tracking and the devices, something like that. And I think right now the only solution we have, there are two different kind of solution, right? The first solution, which is you batch your insert, but devices might not be able to batch. Like for instance, survey 123, one actually sends survey and another device want to send another survey. You're probably not going to be able to scale that, except you have to do batching. Some actually team like Survey 123, they are working in a solution where they will have a middle tier somewhere that collect those device, insert, and then batch that to us, because we won't be able to allow you to have, thousand of insert per second. That's not going to happen. You know what I mean? So the only way is to batch right now, whether you do an extra work to accumulate and batch, or we give you a solution which we don't have right now. So.
Thank you.
You're welcome. Okay, thank you so much. Do you have a question? Okay.
The way it is currently, it's not supported on hosted services, both online and enterprise?
Enterprise support this in the ArcObject feature services, but hosted enterprise is not supporting that either, doesn't support that. We don't have a web solution yet, as part of the web information model. So it is part of the ArcObject. So you'll see it in Parcel Fabric and Utility Network. But for an online feature service or, there is a hosted enterprise, right?
Hosted enterprise and also hosted online?
Yes, those don't have support for that yet.
For both?
For both, yeah. Okay. But they're going to come together. When we have it, both of them will have it. However, if you work with utility network and enterprise, you will have that because it's part of the geodatabase. Okay. You know what I mean?
Okay. And that's 11 on, 11, with utility networks, what's the version it's supported on?
For enterprise?
Yes.
They have it now, actually, for enterprise ArcObject, but for enterprise hosted and for online, probably later in this year.
Okay, thank you.
Thank you. Yeah.
Can we inspect the results coming back from a query sent with a PBF?
You what? I'm sorry.
inspect the results.
Oh, from BBF?
Yeah, like
Yeah, we have lots of converter that convert from BBF to JSON now. It's very easy to write, but we have one. We could actually expose one in the REST API if you like to convert. Is that what you mean? To get the JSON equivalent to the BBF, right?
just to make sure that the PBF result is correct. Not just by replacing it to JSON, switching it to JSON, but just the actual PBF result on the client. And extract the.
Can we take this offline? I will talk to you. Just wait. Just 1 second. Are you guys okay? Okay. Thank you so much.